everyone, thanks for joining. I wanted to do this video on the topic of sending discrete objects throughout your model. And in this case, I'll be showing a method that actually is slightly different, and I'll be explaining how and why you may not want to use object flows that cross context barriers. And what I mean by that is if you were to have some activity that was sending some type of signal or some type of a data object from subsystem A, in this case, to subsystem B, instead of having an activity diagram at the system level that may have swim lanes that would show the object flow going from a swim lane in subsystem A partition to the swim lane in subsystem B, what we can do is actually use activities that are actually modeled in the context of their respective owner. So in this case, we have this activity, which is actually directly owned by subsystem A, will be performed by subsystem A. And we have this activity, which is simply an accept event action that is modeled directly in the context of subsystem B. And what we can do in this method is actually show what that looks like if we were to simulate that, and we can auto-generate sequence diagrams from that. And the true reason for having the ability to generate the sequence diagrams using this method is that object flows do not have any correlation in a sequence diagram. So what we'll do now is show what this looks like in the sequence diagram by auto-generating that. And notice now we have all of these signals keep showing up. That's because signals and call operations can be correlated to an interaction behavior. And that's what you're seeing here modeled in this sequence diagram, is an interaction behavior that simply shows those discrete signals being sent as the signature of the message in this case. So that's neat, because if you stick with this method, it makes sense to say, if we're sending things between different blocks, we can actually correlate that. We can see that in an interaction. And then if you're trying to show things within a block, that's when you may want to actually use activity diagrams that have object flows. What I would recommend if you're trying to auto-generate sequence diagrams is to only have object flows in use in your activities if they are not crossing boundaries of these different blocks. So only keep those in their respective context, and then you will be able to auto-generate sequence diagrams. And that really is because the idea of object flows and that whole concept doesn't correlate to a sequence diagram or an interaction behavior. So this is a very simple example. Now let's flip over and look at a slightly more elaborate example. And in this case, notice we have this context level block. We have some external system. We have this system of interest, and it also has two parts. So in this case, what we'll do is we'll have a signal that will be carrying some data now, and it's called data from external system. As soon as we begin this simulation, you'll see that this starts up. It'll send this signal with that data that says this is from the external system, and it will be sent via this port. Notice it's via external interface, which is this port here, and it'll simply follow that connector path and end up in the system of interest. Now, in the system of interest, I've modeled a behavior where we actually have swim lanes, and this is an accept event action that will be listening for that signal. So this accept event action is actually listening in the context of part one, but then notice because we have this object flow, that object flow is within the same context. So I'm not simply sending it directly over here to part two. What we're doing is actually using this call behavior action to delve a little bit deeper, and that's what you're looking inside of here. So where that data goes in, it actually comes in one level down in that behavior that defines this call behavior action, and it says data within system of interest via P1. So that's going to send it now via its port P1, and that will be part one now, sending it via this connector to part two, and then part two will be executing this receive data behavior, which simply is an accept event action that's listening for that exact same signal, and it will assign that data to a value property that part two owns, which is called part two data. Because we've kept this idea of respecting the boundaries of all of these blocks and not having object flows crossing those boundaries, you'll be able to see all of this in a sequence diagram. So what I'll do is go ahead and run it from this context level now. And we'll go ahead and do one run without seeing it in the sequence diagram. And you see that gets sent there. And then we'll go ahead and restart that, and we'll look at it in the sequence diagram. So you notice that is what happened. That's the result of this auto generation. So as you can see, that is really everything that just happened here. Is we had data from external system that sent the data that says this is from the external system. It went from the external system to the system of interest. And then within the system of interest, we have SOI dot part 1. We now see that we changed it to a different signal name, but it says data within the system of interest. And the data is the exact same data. This is from the external system. And then notice we have the invariant that says part 2 data's value property has been updated and now assigned this string, which is this is from the external system. So that is an interesting way to respect the boundaries of your part properties or the blocks within your system, the objects within your system. And you can see all of that in sequence diagrams auto-generated if you respect those boundaries and you don't have object flows that are crossing those part boundaries. Now, that may leave you wondering, well, how do we then query some of these things out of our model? And if we look back at our block definition diagram, I know a lot of people like to use object flows to cross these partitions or swim lanes because you can actually query that data back out into a generic table. For example, to say, when we have something that's going from this partition to another partition, then we can look at the objects that are going from here to there and use that to define our interfaces. You can still do that. Your meta chains are slightly different, however. So if we look in this generic table, this is essentially what we want to see. We want to see that we had data, which is this signal here, from the external system, sent from external system, and it's received by part 1. And then we also have this data within the system of interest. Notice it's going from the system of interest to part 2. So that is slightly interesting because if you notice, that is actually being accepted here. Instead of it saying it was from part 1 to part 2, because this is in a swim lane, it's actually pulling the context one level higher than that. So there may be interesting ways where you could still do meta chains that would say, I want to see the signal that goes from within this swim lane to within that swim lane. But in this meta chain, what it says is it goes from the system of interest to part 2. What I want to do is show you exactly how you could set up a meta chain like that and use that to your advantage if you were using a method like this. There's 2 different meta chains here. And it's because of the way we have 2 different patterns in that model, depending on what level of abstraction this is at. Notice in this first meta chain, we start at this signal. That's what this whole table is based on. So that's the root element in that chain is a signal. So everything has to start with a signal. Even though you're seeing this signal in the middle column, this whole table is built off of signals. So notice we have a signal goes to the signal event of the signal. And then it goes to the signal event and the trigger of the event. And then the trigger of the event is this accept event action of the trigger. So that is how you actually meta chain to an accept event action from a signal where the accept event action is using that signal. So it is these 3 steps, these top 3 steps that are necessary to get to that accept event action. But then from the accept event action, we can actually go to its allocated to. And what that does is actually looks at the swim lane that it happens to be residing in. It's an allocation. So this accept event action is allocated to that swim lane. And then what we can do is look at the part property of that swim lane and its type. So you could simply look at the part property if you wanted to, but in this case, I actually decided to take it one step further and look at the type for the part property, which is the block that types the part property. So that's what you see here in this column up here. But then there's another meta chain, and it is slightly different. This one is also looking at the accept event action, but it goes to the accept event action's owner. And that's because this is the accept event action that happens to be down in that call behavior action one level deeper. Let's go look at that for a second so you see what we're looking at here. Notice we're actually trying to find part 2 by delving into this received data. So we have to start with this accept event action and then go up a level. So to go up a level, we're looking at its owner. And the owner is the activity that types this call behavior action. So then what we can do is look at the call behavior action of the activity that types the action and then its allocated swim lane. So that's how we ended up doing this meta chain here. If you look at that second meta chain, that is actually how we got to that point. So notice we're going to accept event actions owner, and that happens to be the activity that owns that accept event action. And that activity has a call behavior action of the behavior. So this is the call behavior action that's using that activity. And then we're looking at that call behavior action and what it's allocated to, which is that swim lane. And then the swim lane has a part property and its type. So that's how we ended up with the other one there. Because both of these are typed as outputting a type, we can simply have two meta chains in here, and it is essentially the same thing as a union. And we did not need to perform a union operation because both of these happen to have this exact same output type. So that is how you could use this method. I think it is a very useful way to model and still get the same information out of your model, and also take advantage of that simulation capability where you can auto-generate sequence diagrams from your model and from your activities and those behaviors, because they will now correlate directly to what you would see in an interaction behavior, which is displayed on the sequence diagram. Thank you guys for watching. I hope you found this useful. If your company is in need of MBSE expertise, please feel free to reach out. We would be happy to help your team. Thanks a lot.